All right, welcome to this lecture 1.2 on lines. We're going to look at not only the equation of lines and several of its forms, we're going to look at how to find lines given certain information, and we're also going to look at how those relate to the graphs. What type of equations give us linear graphs, etc. All right, we call equations that give us lines as a graph, we call those linear equations. They're first degree equations. I'm going to give you a couple of examples here. We have the standard form of a linear equation, and that's when it's in the form ax plus by equaling c. So in other words, we have numbers in front of x and y, then we have a constant on the other side of the equal sign. This is in standard form. But notice the x and the y are both being raised to the first power, even though we don't write that. That makes it a first degree equation. We also have the slope-intercept form of the linear equation. If you've done any work in algebra with graphs, etc., you probably recognize the y equals mx plus b. It's one of those things that we pound into your head. But both of these are just forms of the same thing. They're linear equations. Notice x and y are being raised to the first power. And then we have some constants in there. Those are first degree equations, and they always produce, whenever we have x raised to the first, y raised to the first, they always produce linear graphs. Now, the steepness of that line that we see is described by its slope. In the slope-intercept form of a linear equation, the slope is always the value, the coefficient of in front of x there. So the m, when it's in slope-intercept form. When it's in standard form, the slope can be found by taking the opposite of the number that's in front. So the opposite sign of whatever is in front of x there, so the opposite of a over b. When it's in standard form, that will give us the slope of the line. All right. So when we talk about the slope, we talk about the rise and the run. So this particular graph here is of a positive slope. You'll notice it's going up from left to right. There's a positive rise. It's rising as x moves from left to right. So the run is going in a positive direction. You'll notice here that as the run goes in a positive direction, so we're moving from left to right, that the line is actually falling. That's a negative, so we call this a negative slope. And if it's flat, so as we're running from left to right, it's not rising or falling, we say this is a zero slope. And if we're rising straight up without running at all, we say the slope here is undefined. It's also sometimes described as an infinite slope, since it doesn't move to the left or to the right, it just goes straight up and down. So that's a non-existent slope. We'll see how it actually gives us a zero in the denominator, so it's undefined, but it can also be called the infinite slope. Now, how we find the slope if we're given 2 points, say P and Q on a line, slope is, of course, always rise over run. So it's the up and down over the left, divided by the left and the right distance that we've traveled. And this little symbol here, the delta symbol, Greek symbol, represents change. So that's the slope is also described as the change of y, so the rise in our altitude, so to say, as x changes. So we see a horizontal change in our line. Now, the way we measure these, as we saw in the last section, is by subtracting. We can see how far we've traveled upward by subtracting the y's, and then how far we've traveled, or what the change has been with x, by subtracting the x values of my point. And So whenever we take a subtraction, if you'll remember, that's called a difference. And a difference is literally telling us the change in my height if I'm subtracting y's, or the difference between my x's. It's the distance between those points. Now, this little side note shows us that x cannot be the same value, because what would happen is if x is the same number, so let's say both x1 and x2 are 3, this would give me 3 minus 3, which is 0, and we can never have a 0 in the denominator. And so that's why we have the undefined nature of a vertical line. And that's why we have to give this sort of disclaimer over here on the right that the x's cannot be the same number, because that would give us a 0 in the denominator. All right, so we're going to use that formula here to find slope. We're going to take the difference of my y, so y2 minus y1 over x2 minus x1, to give me that rise over run slope value. So what I want to do here is, if I'm going to call this x1, y1, I'm going to call this x2, y2, and it's purely arbitrary. I could have labeled them the opposite. They would still work out the same way. But one thing you want to be careful of here is that we're subtracting numbers. So I'm going to put these in parentheses. Again, we want to be careful, and my y's go on top. So if it's y2 minus y1, that's 3. I've chosen 3 to be my y2. My y1 is negative 1. And for x, since I chose 3 as my y2, then the other 3 also has to be my x2. In other words, it has to go first. And the x value is positive 1. This gives us a great way to contrast these two differences. One of the x's being positive 1 and the other y being a negative 1. As I go through and I change this to an addition and then consequently change the sign of the number that follows it, we see that becomes 3 plus 1 on top, which is 4. On the bottom, again, I'm going to change a subtraction into an addition, but in order to do that, I also have to change the sign of this positive 1 to a negative. So notice that these both changed. The top one changed from a negative to a positive. The bottom one changed from a positive 1 to a negative. 3 plus negative 1 is 2. And so my slope here is 4 divided by 2, which is 2. Sometimes it becomes a whole number like that. Many other times it might be a fraction. But we can think of a positive 2 as being positive 2 over positive 1. We can also think of it as being negative 2 over negative 1, because negative divided by a negative is positive. And in fact, had I had these in the other order, that's what I would have ended up with. It would have been negative 4 over negative 2, but a negative divided by a negative still becomes a positive 2. So the slopes are the same. It's when the top and bottom numbers have a different sign that we end up with a negative. At any rate, I'm going to plot these points out, 1, negative 1, so we can also see what they are on the graph here. 3 and then 3 puts us up here. Using a hard edge, I'm going to draw out the line here. Wish that could have been better, but we're stuck with it. So there we have my line. Graphically, when we look at this, I want you to notice. So if I'm taking it from the positive 2 over positive 1, if I start at any point along the line, and we know that 1, negative 1 is one of my points, that if I go up 2 from this point, so 1, 2, and then to the right 1, because of positive 1, that's change of y over change of x, so up 2 to the right 1, you'll notice I'm at another point on my graph. And I can continue doing that up 2 to the right 1, and you'll notice that I always end up at another point on my graph. This is also true if I go the opposite, the -2 over -1. If I go down 2, so that's my -2, and then to the left 1, -1, I also end up on at another point on the line. And from any point to any other point, if I do the same, so let's say I start at a 1/2 and then -2, going up to the right one, you'll notice that I end up at another point along my line. You can go from one point to another point on the line always by following the slope there. So whole numbers we can think of as being over 1. We look at 2, for example, and say, well, what does that mean? Is it 2 over nothing? No, any whole number is always over 1. So there you have kind of a visual of the slope and what it means. So some just general ideas that we get about the slope, right? The slope is just going to be a number that's kind of thrown at you. But when we're looking at graphs, we tend to scan from left to right, or that's how we want to think. Lines with positive slopes will rise. So as we go from left to right, we're going to see the line going up. Lines with negative slopes, as we move from left to right, will be falling down. I could go back to this first picture that we had here. Here was my negative slope. Here was my positive slope. Moving from left to right, we see that rise and that fall. Second, the greater the absolute value of the slope, so absolute value just means looking at it from, if it's negative, looking at it from a positive, positive standpoint. If it's positive, also looking at it from a positive. Just the bigger the number that we see, the bigger the absolute value, the steeper that line is. So a -2 or a +2, both of these would have a fairly steep rise or fall. It'll just be steeper. If it's undefined, that means we have a vertical line. If the slope is 0, that means we have a horizontal line. All right, this is one of the other forms of a linear equation, but we have a real purpose with this formula. This is called the point-slope form of a linear equation. Point-slope. Point being a point that's on the line, and the slope being the slope that's on the line. So we're going to use the x1, y1 as the point on our line. So we know that the line passes through this point, and then we're given the slope, or we find the slope m of the line. So if we fill in these spots, leaving the x and y as variables, but the x1, y1, we're going to actually put numbers in there, whatever the x value is of the point it passes through and the y value is of the point it passes through, and then m being the slope. We automatically, if we put those numbers in there, we have the equation of that particular line. So the purpose of this is really to help us have a quick plug-in thing that we can use, that once we put those numbers in, we have the equation of that line. So for example, if we want to find the equation of the line that passes through the point 1, -2, and has a slope of 3, then we're going to use the point slope formula, which is y minus some number blank. Again, I'm going to put it in parentheses, equal to m times x minus blank. And actually, I'm going to get rid of that m there, because we're just going to put whatever our slope is there. Whoops. I don't know why this happens, but I do something. I've got to figure out what I do that causes me to get a line there. Okay. So the slope is 3. That's my m, so I'm going to put that right here. And this is the point it passes through, so this is my x1, that's my y1. So 1 going in for x is pretty easy, but -2 is what we have for my y. So again, that's one of the purposes of putting parentheses there. It helps us make sure that we're doing this right. We don't want to leave subtractions if we can help it, especially if it's a minus, a negative. It's much easier seeing as plus positive. So y plus 2 equals, and I'm going to distribute the 3 here, 3x minus 3. And I'm doing that because I want to solve it for y. Generally, we don't like to leave it like this or like this. We usually want to have it solved for y. And in this case, I can do that by subtracting 2 on both sides. That gives me y equals 3x, and negative 3 minus 2 is minus 5. So here is the equation of the line that has a slope of 3, passes through the point 1, negative 2. And notice that I put this into slope-intercept form. Slope-intercept form is always solved for y. So y is by itself on one side of the equation. And so when it's in this form, I see the slope, but I also see, we're going to talk about this a little bit more, the place where it crosses the y-axis, which always has a 0 for x. So 0, negative 5 is my y-intercept, which is why we call it the slope-intercept form. Okay, another example here of how to find the equation of y using the point-slope form. Here we're given not the slope, but 2 points. But as you guys know, we can find the slope if we know 2 points that it passes through. Y2 minus y1, x2 minus x1, using parentheses there, and then filling in the blanks. We're going to put 7 and then 1. And since I use 7, I have to use 3 down here and then negative 2 for my second. We just want to stay consistent. So if I've decided this is my x2, y2, and I do that by putting it first, then I have to use that same x on the bottom there. That gives me 6 over 3 minus negative 2 is the same as 3 plus positive 2. So 5. So 6/5 is my slope here, which is kind of a yucky, yucky one. But regardless, y minus blank equals blank times x minus blank. I'm going to fill in my blanks. My slope I know is 6/5, so I'm going to put that in there. Let's go ahead and put that in a different color. And then let's go ahead and pick one of these 2 points. You can pick either one. Doesn't really matter, actually. They'll both, once we put it into slope-intercept form, come out to be the same. So I'm going to use the one with less complicated stuff. So the 1 goes with the y, and this is negative 2. So notice the second number goes with the y, which is my y spot in the ordered pair, and the x part goes there. I'll distribute the 6/5, so that's y minus 1 equaling 6/5 x, and this becomes plus positive, so that's minus, thinking of it as 2 over 1, 2 times 6 is 12/5. Then to solve this for y, I want to add 1 to both sides, so we add the 2 constants together. 6/5 x just stays as is. We can't add the 1 to that because they're not like terms. This one, the 1 doesn't have an x with it. And with 1, I can say, okay, we'll think of that as 1 over 1. We need to get the same denominator as the fraction that we're adding it to. So we're going to multiply the top and the bottom by 5. That gives me 5 over 5. Now they have the same denominator of 5. Negative 12 plus 5 is negative, 7 over 5. And so that is my final equation there. So here's our first official introduction in the lecture. I kind of gave us a preview of it at the very beginning, but the slope-intercept form of the equation y equals mx plus b, where m is the slope. So when we have it solved for y, we get y by itself. The value that's in front of x always tells us the slope of the line. And then 0b, we always have 0 because we always have an x being 0 when we have a y-intercept, and the opposite when it's an x-intercept, the y is 0. But this gives me the y-intercept of my equation. All right, so if we're asked to graph an equation and it's in slope-intercept form, this is one way that we can do it. I know that my y-intercept here is at 0, 2. Right, so we first plot out, plot the y-intercept, and then, so in this case, it's at 0, 2, so we'll go ahead and put that there. And then second, we're going to use the slope to find a second point. All we need really for a line is 2 points. So if my slope is 2/3, that's positive 2 over positive 3. You could also, since it's positive, think of it same signs, negative 2 over negative 3. I'm going to do both. But remember, the top number is your y, so we first go up and down. So for positive 2 over positive 3, I would go up 2. And then to the right, 3. And then I'm going to deposit another point. So up 2, to the right, 3. That's a 2 over 3 slope. If I go negative, that means down 2, and then to the left 3 in a negative direction. Regardless of which direction you go, you can see that these 3 points line up in a straight line. Is that going to work? Oh. So I use my straight edge there. And put arrows on both sides. There's the equation of, or the graph of that particular equation. With horizontal and vertical lines, a equation with the horizontal line is, I'm going to write this out because, is y equal to k. So y equal to whatever one of the points that it passes through. This is the equation of that line. So it's y equal to a number, like y equal to 2 would be a horizontal line at 2. And for a vertical line, we write it as x equals h. So like that would be x equals 2 would be a vertical line passing through 2 on the x-axis. So notice that when we have a vertical line or a horizontal line, the equations are actually just involve a x or just involve a y. So for y equal to 2, and I'm going to give you an explanation. It's a little weird. People come across this. We're basically wanting to graph a line where every ordered pair has 2 for its k. We can see, let's just looking at these points, this would be at 1 for x, 2 for y. This is at 2 for x, 2 for y. This is at 3 for x, 2 for y. This would be at negative 1 for x, 2 for y. This is at negative 4 for x, 2 for y. So notice that that y is equal to 2 in each of these ordered pairs. That's why we can say that a horizontal line is where the y's are all 2's. Doesn't matter what the x's are, the y is all 2's. That's what gives us a horizontal line. And in a similar way, when we say x is equal to 4, we see x is equal to 4 all along here. And so the vertical line passing through where x is equal to 4 on the x-axis is the graph of where x is equal to 4. This is 4 for x, 4 for y. It's maybe a bad example, but 4 for x, 2 for y, 4 for x, negative 2 for y, and you get the idea. So these are always the easiest graphs in the world to do. All right. Another form, as we talked about at the very beginning, is the standard form of a linear equation where ax plus by is equal to c. So this particular equation is in standard form. I've got the x and the y variables on the same side of the equation. So in this case, a is equal to 3, b is equal to negative 4, and then my c is negative 12. When it's in this form, one of the easier strategies is to find the intercepts of the equation. Graph it by finding the intercepts. Now, you may recall from the previous lecture that when we find the y-intercept, we plug a 0 in for the opposite variable. So to find the y-intercept, we're going to plug a 0 in for x. And then to find the x-intercept, C-E-P-T, there we go, intercept. We're going to find the x-intercept, we have to plug a 0 in for y. So let's go for the y-intercept first. That will give me 3 times 0 for x minus 4y equaling negative 12. So that becomes 0. So we're left with negative 4 equals negative 12. Divide both sides by negative 4 to get the y by itself, or 1y. This equals 3. So 0, 3 is my y-intercept. Then to find the x-intercept, we're going to plug a 0 in for y. So that becomes 0. So I have 3x minus 0, or just 3x is equal to negative 12. Divide both sides by 3. X equals negative 4. So negative 4 is there. My 2 points there, I'm going to go ahead, connect them with a straight edge. Wasn't the best connection, but yeah, it's pretty darn close. And that's the graph of this equation. Now here they actually wanted us to also find the slope, which is rise over run, right? So going from one point to the other, I see that that's a rise of 3 over a run of 4 to the right. So the slope in this case is 3/4, 3 over 4. The other way I can do it, if I'm not using the graph here, is, if you recall what I believe I introduced at the very beginning, when it's in standard form, we take the opposite of A over B. Sorry, I have that written out wrong. It's the opposite of A over B. So negative A over B. And so in this case, the A is 3, so that would give me negative 3 over my B, which is negative 4. Notice that that's negative divided by a negative, so my slope is 3/4. Just like we saw here with the graph. So that's when we talk about an equation that's in standard form, you don't have to put it into slope-intercept form to find the intercepts. You can simply plug in 0 for x to find the y-intercept, and then plug in 0 for y to find the x-intercept, and it's a pretty straightforward way to get the intercepts and hence the graph that corresponds with that equation. Let's talk about parallel and perpendicular lines. If we let L1 and L2 be two distinct lines, and we use the, M is generally used for slopes, so we'll say M1, so that's the slope of line 1, and M2 is the slope of line 2. Then if L1 and L2 are parallel. So I'll just draw a couple of parallel lines here. Two lines are parallel if they never cross each other. L1, L2. If that's the case, then the slopes, they're running and rising at the same rate. So slope 1 would be equal to slope 2. Now, if they're perpendicular, meaning they intersect each other at a 90-degree angle, so if this is my L1, the perpendicular of this L2 would come at it at a 90-degree angle. If they're perpendicular, then their product will be equal to -1. So that's one way of showing it. Another way to show, let's see, the slope of M2. So that's the slope of line 2 would be equal to the opposite reciprocal, so 1 over M1. So whatever the M1 is, we're going to flip it and then take the opposite sign of it. The way that you can see why that works, if I take M1 times M2 in this case, so that would be M1 times M2 is negative M1, or -1 over M1. The M's cancel, and I have 1 times -1, which is -1. So their products give me -1. So perpendicular lines have the opposite sign and flipped version. Let's look at some examples here. All right. So L is 2x minus 3y plus 6 equal to 0. We want to find the equation of the line. So I'm going to put this just into standard form real quick by subtracting 6 to the other side. The form they gave it to us is not any kind of form at all, but it is really close to standard form. So I'm just going to rewrite it in standard form. So we see our A is 2, our B is -3. So the slope of this line is the opposite of A, so -2 over B, which is -3. So the slope is 2/3. All right, we want to find the equation of the line that passes through this point 2, 8, where they are parallel. So line 1 is parallel to the line I'm given. Okay, so if they're parallel, they're the same. So I know that the slope is also going to be 2/3 for L1. So for L1, so here we go, y minus y1, so blank, equals slope, which if they're parallel is the same, so 2/3 times x minus x1. And then the y is 8 and the x is 2, so we put those in their respective places. So I have y minus 8 equals, I'm going to distribute this, 2/3 x minus, this is 2 over 1, so 4, 2 times 2, and 3 times 1, 3, 4/3. Adding 8 to both sides. This is 8 over 1. We need a 3, so I'm going to multiply the top and the bottom by 3. That gives me 24/3. So -4 plus 24 would give me positive y equal to 2/3 x plus 20 over 3, 20/3. And you can just leave it like that. It's a lot easier sometimes to work with equations, fractions that are improper as opposed to mixed numbers, believe it or not. All right, so this would be the equation that is parallel to our line and passes through the point 2, 8. Now let's do the one that's perpendicular to it. So if my slope of L is 2/3, then L2 will have a slope that's the opposite sign, so it's going to be negative. And then we're going to find the reciprocal of this, which means flip it, 3/2. Opposite sign, so this one's positive, take the opposite sign, and then we flip whatever we have there. 2/3 becomes 3/2. This is the line that is perpendicular to the original line. So the opposite signed reciprocal. All right, plugging everything in, it's the same, passing through the same point, so I'm just going to go ahead and put that in there. We do have a different slope, which is going to work out for us nice when we distribute. This would be negative 3/2 x, and that's a negative times a -2, so that becomes plus. The 2's cancel out, so we're going to go with 3/1. We'll just write that out over here. Negative 2/3 times negative 2/1. We have the same number in opposite parts of the fraction. They cancel, and then that's a negative times a negative. So positive 3 is what we have left. Adding 8 to both sides, that gives me y equal to negative 3/2 x plus 11. Here's the equation of line 2, which is perpendicular to my original line and passes through the point 2, 8. This concludes our lecture for now, and hopefully this helps get you started on the homework. Finding the equation of lines, also being able to graph them in various different scenarios.